Dear students, now we solve question number 19 from the question series of IIT JAM 2024 mathematics question paper, and this question is given from real analysis continuity of a function, and the question is, let x belongs to the set of real numbers R. Let box x denote the greatest integer less than or equal to x. For xy belongs to R, define minimum of xy is equal to x if x less or equal to y and y otherwise. Let f close interval minus 2 pi to 2 pi to r be a function be defined by f of x equal to sine of minimum of x comma x minus box x. For x belongs to minus 2 pi closed interval. Consider the set S is equal to x belongs to minus 2 pi comma 2 pi closed interval such that f is discontinuous at x. Which one of the following statement is true? There are four options. Option A, S has 13 elements. Option B, S has 7 elements. Option C, S is an infinite set, and option D, S has 6 elements. So let us try to solve this problem. The given function f minus 2 pi closed interval to r defined by f of x equal to sine minimum of x comma x minus box x. So first we find out that portion minimum of x comma x minus box x. Here it is defined that minimum of x comma y is equal to x if x less or equal to y and y otherwise. So from here we find out minimum of x comma x minus box x. When here the interval is minus 2 pi to 2 pi, so here 0, and from 0 to 2 pi there are 6 integers 1, 2, 3, 4, 5 and 6, because 2 pi means pi equal to 22 by 7, so 2 pi is equal to 44 by 7, so it is greater than 6. So therefore there are 4 integers, and here also 4 integers, here 6 integers, and here also 6 integers, 1 to 6, and here minus 1 to minus 6. So minimum of x comma x minus box x. When x is negative, then this is greater than x, because when x positive, x greater than this. So when x is negative, this is greater than x. Therefore from minus 2 pi to 1, minimum of x comma x minus box x is equal to x. When minus 2 pi less or equal to x less than 1, and when x is bigger than 1 and 1 to 2 pi, then x minus box x. When 1 lesser equal to x lesser equal to 2 pi, but x minus box x is greatest integer function, so we find out first this portion also. X minus box x means x minus 1 when 1 lesser equal to x less than 2 is equal to x minus 2 when 2 lesser equal to x less than 3 is equal to x minus 3 when 3 lesser equal to x less than 4 is equal to x minus 4 when 4 lesser equal to x less than 5 is equal to x minus 5 when 5 lesser equal to x less than 6, and x minus 6 when 6 lesser equal to x lesser equal to 2 pi. Therefore, the given function is f of x equal to sine of this is equal to sine x, because minimum of x comma x minus box x means x when minus 2 pi lesser equal to x less than 1. Therefore, sine x, this is equal to x, sine x when minus 2 pi lesser equal to x less than 1. This equal to x minus 1 when 1 lesser equal to x less than 2. So this equal to sine x minus 1 when 1 lesser equal to x less than 2. Similarly, sine x minus 2 when 2 lesser equal to x less than 3. Sine x minus 3 when 3 lesser equal to x less than 4 is equal to sine x minus 4 4 lesser equal to x less than 5. Sine x minus 5 5 lesser equal to x less than 6, and sine x minus 6 when 6 lesser equal to x lesser equal to 2 pi. Therefore, the function f of x is defined by this. Now we see that when x belongs to minus 2 pi to 1, when x belongs to minus 2 pi to 1, minus 2 pi to 1, when x belongs to minus 2 pi to 1, the function is sin x, which is a continuous function. So for minus 2 pi lesser equal to x less than 1, the function is continuous. When x belongs to 1 to 2, sin x minus 1, it is also continuous function. 1 to 2, it is also continuous. From here to here, continuous. And 1 lesser equal to x less than 2, the function is continuous. Similarly, when 2 lesser equal to x less than 3, sine function is also continuous. Sine is continuous when 3 lesser equal to x less than 4, and when 4 lesser equal to x less than 5, when 5 lesser equal to x less than 6, and 6 lesser equal to x lesser equal to 2 pi, function is continuous. But at the integer value, the integer values means when x is equal to 1, when x equal to 1, we see that limit x tends to 1 minus f of x is equal to limit x tends to 1 minus f of x means sin x. So limit x tends to 1 minus sin x is equal to sin 1. But limit x tends to 1 plus f of x is equal to limit x tends to 1 plus f of x means sin x minus 1. So here sin x minus 1 is equal to 0. So limit x tends to 1 minus f of x is equal to sin 1, and limit x tends to 1 plus f of x is equal to 0. Therefore limit x tends to 1 f of x does not exist. Limit x tends to 1 f of x does not exist. Therefore f is not continuous at x equal to 1. Similarly, at x equal to 2, limit x tends to 2 minus f of x means limit x tends to 2 sin x minus 1. So limit x tends to 2 minus f of x is equal to limit x tends to 2 minus f of x means sin x minus 1. So here sin x minus 1 is equal to sin 2 minus 1 means 1. But limit x tends to 2 plus f of x is equal to 2 plus f of x. 2 plus f of x means sin x minus 2. So 2 plus limit x tends to 2 plus sin x minus 2 is equal to 0. Therefore at the point x equal to 2, limit x tends to 2 f of x does not exist. Therefore f is not continuous at x equal to 2. Similarly, at the point x equal to 3, x equal to 4, x equal to 5 and x equal to 6. Therefore there are 6 integer 1, 2, 3, 4, 5 and 6 where f is not continuous. Therefore the cardinality of the set S is equal to x belongs to minus 2 pi to 2 pi. F is discontinuous at x equal to x. F is discontinuous at x. We see that the function minus 2 pi to 1 is continuous because here the function is sin x. After 1 to 2 also continuous, 2 to 3 also continuous, 3 to 4, 4 to 5, 5 to 6 and 6 to 2 pi, the function is continuous, but at the integer point 1, 2, 3, 4, 5 and 6, the function is discontinuous. Therefore, the cardinality of the set S is 6. That is, f is discontinuous at 6 points. Therefore, option D is true. S has 6 elements. Thank you.